Hello everyone. With the growing popularity of EC motors, or electrically commutated motors, for their power output and their energy savings, these motors are becoming more and more popular and are being used more and more in hood ventilation applications. The most common motors are fractionally horsepower motors, but the availability of larger motors is increasing. There are several options for controlling these motors, but in this video I'm only going to cover one of those, and that's wiring our EC motor to one of our hood control packages. Be sure to follow all safe work practices, especially the use of PPE. All circuits should be de-energized prior to any wiring or service. Remember, many of our controls will have more than one circuit that will need to be turned off. After de-energizing a circuit, verify that the circuit is dead, then lock out and tag the breaker. It's important to check the equipment on the job site as well as the job site schematics to see what type of equipment you have and how it's going to be controlled, because there's several ways to control an EC motor. The first is a controller mounted on the fan itself, which may control the motor when power is applied or controlled remotely. The second way we control EC motors is through a hood control package. This video will only cover wiring the EC motor to the circuit board in the hood control package. In this scenario, the high voltage power will be applied to the fan all the time, and only the low voltage signal power will be controlled. Before we get to the wiring specifics, let's look at how an EC motor works. The motor receives high voltage power just like a traditional motor. However, in many cases, the power is present at the motor all the time and fed directly from a breaker in the building breaker panel. In order to run, the motor must receive a pulse width modulation, or PWM signal, supplied by a fan motor controller, or in this case, directly from the circuit board in our hood controls. This low voltage signal is fed to the motor control module located on the motor, which in turn provides a soft start and controls the motor speed. Now let's look at how to wire a fan to our hood control package. Start by wiring the high voltage for the motor straight to the breaker so the fan will have standing power all the time. Then locate the low voltage wires in the J box of the fan and wire these with twisted shielded pair to the hood control package and land them on the correct P terminals. Let's look at a real-life example of how this gets wired. Looking at the job schematic, we see the high voltage listed here for each fan, and the low voltage listed here for each fan. Now let's take a detailed look at the low voltage wiring. Locate the low voltage wiring on the fan and run that down to the hood control package. These wires will be terminated on the hood control package on the P terminals located here. Note that the low voltage wiring is polarity sensitive. If you get the polarity wrong and apply power, the corresponding P terminals will be shorted. There are 4 sets of P terminals, and it's critical to get the correct fan on the correct terminals by matching the fan number to the schematic. Matching the fan to the correct terminals is critical to air balancing and proper fan operation in a fire condition. Once wiring is complete, apply power and turn on the fans to test the fan operation. If you have any questions on this or any of our products, feel free to call or email. Thanks for watching.